Okay, exploratory data analysis, right? Topic 5. So we'll go with what are the objectives we want to do this particular chapter. And so mainly we want to go with the reason of this particular exploratory data analysis, who was behind. Okay, so it all began with John Tukey. Okay, so with something related with data components. Two components, which is smooth plus rough. Okay, so the reason why we wanted to go with this type of an understanding, okay, like data is smooth plus rough and pattern behavior plus random variation. So by now I show that you would really appreciate the reason why we are talking about this smooth plus rough. Okay, pattern behavior plus random variation. So I'm just wanted to know, like, what is your understanding about this type of two components when you're talking about smooth plus rough and patterned behavior plus random variation. So what is your understanding? What is your input on this particular type of an discussion? Okay, when we say two components, right? Smooth plus rough. Yes, class, are you able to understand? So why do we say data is can be these two types, smooth plus rough? Okay, Raymond. Okay, Chai is not sure. Fine, no issues. Thank you, Chai, for your input. From Raymond, easy and readable. Okay. Thank you, Praveen. Okay, so I think we have some understanding here. So rough is raw data, smooth is some sort of a clear data, right? Okay. Okay, can we go furthermore to give some more understanding on this smooth or what we call as the rough data? Okay, so maybe the structured data, okay, can be put under this type of a smooth data, and those unstructured data, okay, can be put as a rough data. So usually the data is a mixture of these two, right? So as a data scientist, right, you'll be having exposure to these types of data, right? It's not always you're talking about clean data, or not always talking about rough data, okay, which is unstructured data or the data that actually has noise. Okay, yes, of course, it can be one particular type of characteristics of rough data, and it's more unstructured in the sense we are not very clear about the format. Every time the format can differ, right? So when you talk about if you write the schema, right, before reading it, or you're going to read the schema before writing it. So all these types of dialogues can happen, right, when you wanted to go with the further step of transformation and modeling, right? So these things really cater to these what we call as clean or smooth plus rough, right? So are we getting some understanding here? Are we fine with this? Do you have any other thoughts? Right. So this is what we really try to bring out on smooth plus rough. So similarly, when talking about pattern behavior plus random variation, right? So this once again, the reason towards why we introduce some sort of statistical details, right? So not all time, right? We have good number of observations, right? That actually tend to move in one particular direction, right? And that is also yesterday, I think we discussed about the reason why we go with the t-test and then the different ways in which we wanted to go with the t-test, right? So maybe one particular reason is we have PAT t-test, right? And maybe right because we have PAT t-test because we know that we have the observation done before and after, right? So that is the reason why we have some sort of a PAT t-test. If in case we do not have these types of what we call as so-called well-defined data, right? Which means that we do not have both the before and after readings, right, of a particular experiment or of a particular case study, right? So there we need to have these types of reasoning, okay, to which type of statistical detail we are talking about. So that should be an understanding about the random variations and pattern behavior. We are sure that we can understand very well pattern that is being underlined in any particular type of a data. So we need to be very sure that it's not only about pattern behavior always, so we can also have random variations in our data, right? So I think we are getting some clarity here. So from Chu, raw data consists of outliers, smooth data already processed to eliminate outliers. Yes. Yeah, can. Okay, so this is one attribute. What you're trying to provide here is an understanding about how we are trying to give some meaning to this type of smooth and rough data, right? So thank you, Raymond, Chai, Praveen, Liu, and Chu. Okay, so hope all of us are very clear in this understanding, right? So only these types of questions could be what to say, like be tested, okay, in interviews or maybe even in our test, okay. Like how we try to define some sort of a pattern data, or how we go with saying that this particular data is a rough data or something like that. Okay, so is everybody clear in that understanding? Okay, thank you. So next we go with what is called as the measures, right? So we display or we start talking about measures. So here this is about the resistant measures or displays, right? So how we go with that? So it is very well said that we are always being influenced by changes, right? That is the reason why there is always something happening. So events happen because of some changes happening, right? So stages happen because of something happening to that particular force, right? So maybe solid to liquid or liquid to gas, like ice being melted to liquid, and liquid when we heat it comes to what we call as a gaseous state, vapor state, right? These all things are happening because of some external forces, right? So these things can also be calibrated in a way that how are we trying to understand, how are we trying to measure these things in a vivid manner, okay? So the little influence by changes in a small proportion of the total number of cases is to be really understood. So that is a real reason why we are always emphasizing that we have a very good understanding about the data source and about the data that we are actually talking about, right, or taking into consideration for the particular study. Okay, so please take note of these measures and displays, right? And as such, yes, so I think we did get some inputs on outliers, right? So resistant to the effect of outliers, right? So resistant to the effect of outliers is also one of the key measures that we need to understand, right? Because when we started with how we are trying to define the data. How are we trying to put a boundary to the data, saying that, okay, only when we are having a data that is bound to a particular set, right, then we can have functionalities onto the set, okay, to get more understandable nature of the particular data. Right. So if in case those data points are outside the set, so we know that those are outliers. And how are we trying to effect them in a way to understand their logic? Okay, is further to be noted. Next, it emphasizes smooth over rough components, right? So how are we trying to get an understanding on this? Emphasize smooth over rough component. Okay. what is our understanding of emphasizing smooth over rough component? Is the question clear? When you talk about emphasizing smooth over rough component, so this is actually one stage of our data pre-processing. So the reason why we are talking about emphasizing smooth over rough components is which particular type of a data will you prefer to use for your model? Yes, right. It's something like removing outliers. Good, right? So we wanted to do all the pre-processing details, right, on the data so that we are able to go with a smooth data which is more valid for our data modeling, right? So when you go to the next module, right, when we are going and you're being introduced to this machine languages or machine learning curriculum, right, where you will be introduced to more algorithms as such, right, to prepare the model. There your emphasis is only on model building. To build a very good model, right, you need a very clear data. So this clear data is obtained only after you do all the other pre-processing effect on the particular data, right? So once again, this particular data, we are going to do some more applications, like maybe we are using the data set, okay, like some of the data set, like 80% will be for training, right, and maybe 20% for testing. So it could be 80 plus 20 or 70 plus 30, depending on how well you're going to model your particular algorithm, okay, for effective tuning as such. Am I clear? Are you able to get a valid reason why we are talking about all these things? Yes, Ang. Remove outliers, we smooth the data to find patterns, right? So I'm sure all of you are very clear in this understanding, right? So the reason why we are trying to do all those things is for your next stage of building a model, right? So in data management, we are talking all about these data so that we are very clear to pass on our data to the next stage of modeling, right? Fine. Any doubts so far? Sure, we are just trying to talk about the details, right, which really need to be understood. And this is all we are going to be tested for the reason towards data explanatory analysis.
So can I ask you one question? What's
Sure.
the difference between transformation and modeling?
Okay, good. So not all modeling needs transformation. Okay, so that is to be understood. Not all models need data transformation. It's once again based on what type of a model you're going to use and what type of data that is being tested on. Okay, so data pre-processing will be effected. Okay, and from data pre-processing we can go for data transformation in the sense, I think we did discuss some small amount of those things, like whether we are going to do all those types of attribute reduction, right, or whether we are really going to go with some sort of an redundancy check. Okay, and these things are attributed to the particular data set. Is it clear, Ang?
Yes, sir. Thank you, sir.
Okay, thank you. So that's the reason why we are emphasizing on having good clarity on our data set, right? So the concepts apply to statistics and to the graphical method. So that's the reason why we are trying to have both these things as a concept study. So in data science process, okay, we are talking about raw data being collected and the data being processed. So the data process can be cleaned, right? Once we are trying to go with the exploratory data analysis, right? And you can very well see that from here, after cleaning the data, right, we go to the exploratory data analysis, and once again back it is going to the data processing stage, right? So why is this happening? So we will understand that in exploratory data analysis, right, we are very well trying to learn about some of the details of the particular data, right? So here, actually, it can also be something like this. The reason why we are talking about this is once we are able to understand this logical steps, okay, and all the effective methods to do with exploratory data analysis for the particular model, right, which is going to be used. So based on that, that is the reason why I was emphasizing the thing that, okay, whether we are really doing all the other data pre-processing, data effective techniques to help modeling. Okay, and with modeling, what we can do is it helps to have good communication and visualize reports. Okay, and you can very well see that only from communicative visualize report we are taking to the make decision. Okay, fine. So this we need to have some sort of an understanding, and we have some data product. Data product, once again, what we do, we feed to the real entities, the real world where we are trying to do the applications. Okay. So the question here is, okay, after we have done the model, after we have done the accuracy part, check the model for the effectiveness, right? We are saying that we are going to communicate, visualize, and report them to make decisions. So the highlight here is once again on how you are trying to produce a very good report. How are you able to justify your findings? Right. We'll be able to give a report, we'll be able to visualize the particular report, but it's all about how we are trying to justify the particular report. That's the reason why the question of why the big data failed, right? Or how the corporates that use the big data failed, right? Are we getting in terms with this?
So for this case, which part is the data transformation?
Okay, so here we say data is processed, right? And then we go for data cleaning, right? Okay, so you may ask the question, right? Okay, why data is processed and the data is cleaned? Right? Do we have this? Sorry.
For the clean data set, data is processed is under pre-processing phase, right?
Yes, right. Okay, that's the reason why I was even informing in the previous stage, right? Whether we are trying to do this or do that. Cleaning, data cleaning is coming under part of that particular stage, right? So here, that's the reason why we can see here in exploratory data analysis, even though after the data clean is fed into it, it once again also is reverted back to check whether all the pre-processing is being enforced, and then once again whether any cleaning need to be done. This clean is not only about missing data, it can also be about other valid things that could be affected. Is it clear, Rang?
Yes, sir. Then can I say that the data transformation is happen during the models and algorithm part? Is it?
No. Data pre-processing will not be done during that.
I mean, transformation
Data
inside this chart.
transformation.
Yeah.
Data,
Is it models and algorithms is the part of data transformation?
okay, fine. So that once again, it's based on the particular model you're talking. So if in case it's going to be neural networks, right? If in case the algorithm that you're talking is about neural networks, all
Yes.
these CNN, all those things, right? So there, yes, of course, because you need to have fine tuning, hyper parameter testing and all those things, right?
Mhm.
So those things will be affected during that part, but not always that is the case. That's the reason why I said it depends on the data set and also what type of modeling we are trying to do. It affects that also.
Got it, sir. Thank you, sir.
Right. And the reason why we are going with one particular type of an stage process is to make sure that for now as a data management, right, we are very clear with what we wanted to do with having our data managed. Okay, because if in case we are talking about scoping of modeling also with part of data management, then it may cause some overload for now. Okay, thank you for that understanding. How about others? Is any doubt so far? Are we clear with our understanding? This class, any doubts? Is everything okay? Even if any slight doubt, anything, okay, we can discuss once again. This Chai, very good. Chai is clear. Okay, so Praveen is fine. Okay, if anybody having any doubt, okay, please make sure that okay, we can discuss on it. Okay, so that we are very clear on our progress. Okay, so now are we able to understand this? The reason why we are talking about decision making, right? So when we actually do decisions, it is only after we have created the model, right, based on the particular algorithm. Okay, and we have tested the model, we have fine-tuned the model, okay, and the model is giving us a very good result, right? So once again, that is the reason why the data that you are using, okay, will be both used for training and testing. So you need to have some sort of allocation. So these things you'll be studying in when you do modeling, but now, okay, we have to have some sort of an understanding about what are we trying to do with the data that we have processed and managed. So all these things will lead to our next stage of modeling, right? Is everyone clear in this understanding? Like so what are you trying to do now is just about taking the data, understanding the data, understanding the variables, giving some sort of an note on the variables, right? Doing the regular stuffs of data transformations, right? Or in case you want to do data pre-processing before because of your nature of your data, right? Fine. Okay, so that is the reason why we say not all the data will follow all the steps. Okay, and that's a good way of saying that it's all regarding the smooth or rough data, whether it is a pattern data or has a random variation in your data, right? Because not all the observations are going to be the same, right? Fine. Okay. So here we have some understanding about some values where we are going to discuss some sort of an technique called binning. Okay. So randomly we have some categories, some 6 categories. Okay. Some values. Okay. And some range. Okay. So here you can see that we are trying to put 4 bins for the 6 categories. Okay, so you for now you just understand that bins. Okay, maybe you can visualize them as buckets. Okay, or some sort of a store where you wanted to put those data. Okay, so a range of 15,000 to 20,000. Okay, can be put under rank 1. And a range from 21K to 30K in rank 2. Okay, and a range of 31K to 40K in rank 3. Similarly, a range of 41 to 50 in rank 4. So here maybe the 7, 10, 21, 30 for your, just for the sake of understanding, you can just think that those are number of observations. Okay, so are we clear in this slide? Okay, thank you. Right. So EDA, right, which is exploratory data analysis and visualization are very important steps in any analysis task. Okay, so the way we analyze and visualize. The reason towards all these effective techniques is to make sure that we are able to get to know our data, right? Very essential thing. We should be able to very well know about our data. Okay, so don't jump into any particular conclusion. Okay, so I want to do these types of steps. I want to do this particular type of an analysis without really having good knowledge about that particular type of data. Okay, yes, of course you can. Okay, you can go with testing. Okay, you can go with any type of processing, because of for now you're in academics. Okay, because all those things, okay, you can categorize as putting them under grades or marks, all those things, fine. But when you're in the real time, okay, you may not have this type of liberty of maybe because of time constraint and all those things. Anyway, you have your team, right, where you can discuss about the effective ways you're going to do with that. So I think I'm sure that most of them who are in this particular type of a domain, okay, will always have a team working on it, right? Am I clear? Am I right on this? Okay, so we have from Wong, what circumstances we need to perform binning? Yeah, sure, Wong, we'll discuss that because our slides are going to include those things. Okay. So I think we are making some sort of a note here, right? So anybody who are already in this type of an data analysis team, so how you effectively do that in your organization? Or not so exactly that this is how you do? I'm sure many of you are. Okay, not so is it? How about Ang? How about Tan, NG?
So you're asking about what actually we are doing for data exploration, is it?
Yeah, in your team, in your.
Actually, we will study column by column to identify the distinct values from each variables, and from there we will decide which what type of variables that we can use as our slicer or something like analysis part. And then if something is not cannot use, then for example, just now the number we have to do a grouping. In my company using Power BI, we are using DAX formula to categorize it into different bin or groups, and then from there we create our visualization based on that. Yeah.
Very good, very good. So I think already Wong has the answer now. So when do we actually do performing binning? Ang?
Whenever we see the data is quite messy, and then we're trying to group it so that we can use it for analysis purpose. Otherwise, it's very difficult to justify which group is that. For example, age, we have a different age. We're trying to group it. A teenager is an age, and then youngster is another age, and then mature or senior citizen another age, so that we can see the pattern. Otherwise, it's very difficult to identify.
Thank you.
Thank you, sir.
Okay, so did we do anything like that before in our previous exercises, activities, anything like that? Did we do anything like grouping? Do you remember? So we did something called grouping, remember? maybe before class, not yesterday, but before that. So what we actually did, we tried to categorize, right, the particular contents, right? I'm not sure like which particular example we did, but we did something like that. So to categorize based on, even yesterday, like when we start talking about year, right? So based on the year, did we categorize run? Do you understand?
Yes, sir. I'm trying to look for the exercise that we do in the past for the grouping part. I forgot already. Sorry, sir.
Okay, no issue, no issues. Because sure, others are also recalling that. Okay, fine.
So I think I found the group part already. It's using the
Okay.
SGplot VBox pulse one, and then we have the group equal to smokes, non-smoker and non-smoker. Then that's that we group it into different data label.
Right. So that is one way of actually we are trying to do some sort of a grouping, right? So make us have some sort of a clarity on the data. Am I right? Okay. So I'm sure all of you are also trying to recall what we did. Okay, no issues. We once again do these things because the thing what we are doing today, the exploit data analysis, right? Some not everything. Some of them we already have started practicing in our lab activities as such. Okay. So now we are trying to dig deeper with the theoretical reasoning. So the reason why we say that we need to get to know more about our data, right, to we can use these types of techniques like distributions, okay, from where we can have the symmetric, normal, and skewed, right? So when you're talking about this, right, so we are talking about our understanding about how the data actually is being read, right? Whether we are talking about our normal distribution, right, or what type of a data, okay, whether it is left justified or right justified, and whether it is oriented towards positive or negative, right? Or if in case we're talking about t-test, whether it is two-tailed t-test, right? And usually my suggestion, I think yesterday when we discussed about the t-test, it is my suggestion is in academics, okay, always go with the two-sided t-test, okay, so that we are able to have some good considerations about your data. Okay, so because the data should talk about itself, so when talking about the t-test, it's good that you have a two-paired t-test, right? So one is about the distributions, right? And another one is about the data quality problems associated with that. Okay. So in data quality problems, you can also include all those essential details that we need to do, right? Cleaning, right? Finding and all those things. Okay. And hard code encoding and all those essential things. And outliers, yes. Okay, we need to identify the outliers. Correlations and interrelationship. Okay, so when we go with correlations and interrelationship, we're trying to get an understanding about the attributes in a way, okay, whether we really wanted to go with those attributes or like how we did yesterday, right? Whether we wanted to create another more variable, okay, for better understanding or for better readability, okay, and for reporting. And subsets of interest. Okay. So all these things will correlate to our understanding about how we wanted to go with our data reading skills, right? And lastly, about suggest functional relationship. Okay, so what type of functional relationship will you suggest? So far with your understanding, okay, if in case we wanted to say suggest functional relationship, what type of functional relationship will you suggest? Yes, class. Any idea? Okay, the question is, from getting to know your data, right? We are able to understand the distributions, data quality problem, outliers, right? The reason why we go with subset of interest. What is the suggest functional relationship? What is it that we are trying to go with suggesting a functional relationship? Is the question clear now? Very good. Okay, so that is one of the functional that we discussed so far, like what type of an analysis, right? For example, age is independent versus health dependent. Good. Provide modeling is another stage. Okay, that is another stage. So here we're talking about how are we trying to get some sort of a relationship between the attributes and what type of functionalities that can be operated within that particular type of an attribute. Is it clear? Good, thank you. So is everybody clear with these things, like what we're trying to do here? So we can say sometimes it is EDA or visualization that might be the goal, right? So the reason towards having the exploratory data analysis and visualization, okay, or which particular type of a technique we are trying to go should be effective the goal. So this is what we are trying to justify. Okay. So in a cake bakery, okay, when you're putting that as a data visualization, what are we trying to understand here? So we are having something like different types of ingredients, right? Yes, Khalid. Yeah. Let's go dependent. Fine. That's also a good example. Fine. So from Noor, Sabrina, donut flavor. Okay. Percentage of ingredient to make a cake. Overall sales in the cake bakery. Okay. Flavor of cake by popularity. Okay. Done. Very good understanding. So with this, are we able to do any interpretation? Will this be good enough for us to do any interpretation? Yes. How many yes? How many no? How many maybe? How many don't understand? Don't mint is the most preferred by cake by customers. Okay. So thin and mint is the most important ingredient in making a cake. So from Raymond, sales by SKU. Right. So I'm sure this particular type of interpretation will help. Okay. Sales to be improved. because this gives us an understanding about how we are going with a type of an visualization. Okay, and how clear are we in giving the storytelling, okay, on how this particular type of an case study of distribution of customers in buying pattern of a cake, right? So are we clear in this? Will this be some sort of an understanding, like if in case for your data set you will be able to produce something like this, or maybe you can give some sort of hypothesis in the way. Okay, looking at your data set, okay, maybe I want to go say that, okay, based on that, my sales for this particular quarter will be good, or maybe customer likes too much on this particular type of an category, right? Are we able to get some understanding on that? So from Chai, store keeping unit, or we can call item number. Okay, fine. So these are some terminologies, okay, based on the industry. Hypothesis: we need to store more ingredient to make thin mints flavor in the upcoming sales. Good. So this is one hypothesis, right? So to prove or disprove is about how good you are in preparing your particular analysis and bringing out your result, right? Agreed? Are we able to understand this concept now? What we're trying to do now, right? How we are trying to get with some hypothesis on this particular type of an visualization. Fine. Thank you, Caleb. Thank you, Chai. Thank you, Raymond, Ang, Noor, Sabrina, Tan. Hope everybody is clear, right? Okay, fine. Exploring data. Okay. So this particular data, right, will give us a very good understanding about the two ways of exploring the data, right? So it could be both descriptive statistics or graphical illustrations. Okay, so when you go with descriptive statistics, we need to deal with the categorical data, continuous data, right? So in categorical data, we're talking about the frequency percentage. In continuous data, we're talking about the measure of location. So here, measure of location, we can go with the mean and median. So like how yesterday when we're talking about the box plot, right? So we know that there are whiskers, right, which gives us an understanding of what where are the Q1 and Q3, right, and the IQR, the interquartile range, right, which is 50%, gives us an understanding about where our median and mean lies. Right. So when you're talking about the median, we very well understand that median is going to be the middle part, right? So 50% is above, and 50% is going to be below the median. Right. And which particular way we are discussing gives us a more understanding about the measure of location. That is what we are trying to portray here, right? Okay. Next is about measure of variation, which can be used to detect through standard deviation, range, the min max values, right? The upper bound and the lower bound, and the LQ and UQ, which is going to be the interquartile ranges, right? Next. So this is about the descriptive statistics. So when you go about the graphical illustrations, we're talking about the categorical data where we can use bar chart or the clustered bar chart with two categorical variables, like I think we discussed yesterday, right? We can use that, or we can go with the bar chart with error bars. Okay, so to distinguish clearly about those details. And continuous data, we can have histograms that can be plotted against a categorical variable, box and whisker plot that can be plotted against a categorical variable, dot plot can be plotted against a categorical variable, scatter plot to continuous variables, right? So I think for yesterday example, we discussed about pulse and ran, right? Okay, so are we having an understanding on this? What are the things we are trying to explore in our data? Okay. Okay, thank you. So regards continuous and discrete, okay. Quantitative data and qualitative data. So this actually make sure that you can also give these details in your assignment, okay, like which are the things you wanted to put under continuous and discrete, like quantitative data and qualitative data. So measurements in case of time of day, like what are the units you're going to use, right? Hours, minutes, seconds are going to be under quantitative, right? So qualitative is all about ordinals, right? Like 1, 2, 3, because we're talking about how we are putting a quality in measurement. Like you can only use quality measurement through ranks, right? Whether it's taste good, taste normal, or taste better, you can only rank them, right? So that is the reason why we put them under ordinal things. So hope everybody's getting an understanding on this, right? So when talking about binary, it can be only 1 or 2, right? 0 or 1, AM, PM, before, after, fast, slow, hot or cold, right? So when you have something like light, medium, dark, okay. So if in case you're going to have an category, right, of room types, right? Room types in the sense whether it's going to be normal, deluxe, super deluxe, right? So those things can also be very well understood that it is going to be under discrete, which is going to be under ordinal values, right? So are we clear in this understanding? Yes, Noor, thank you. So we have a very good document here from Lucian. Sorry, sir, allow me to top up on the visualization on the cakery diagram. I think it would be better if there is a title to the diagram for better understanding for user. It seems like the sales performance of the cake bakery instead of the ingredients to me, because those items in the chart seems like the product names instead of the ingredient names. Good, right? So this is the what is we call as the justification and interpretation. That's the reason why we didn't put the title. Okay, thank you, Lucian. Any thoughts to this? Okay, so make sure that we are very clear in giving this particular explanation. That is the reason why we are insisting on this particular thing, right? How well are we able to communicate, visualize, report? This will make good decisions, right? Only then it is viable to go with getting a new data product for our real terms, right? So this actually is understanding about the not only about ingredients, it's also all about how we are putting it in both sales performance as well as our product names, right? Because product names also influenced by ingredients, right? So nothing wrong in how we are trying to justify, but how well are we able to get out our decision is what is very important. Thank you for the input, Lucian. So can you share the PowerPoint later? Seems my PowerPoint doesn't have the example of descriptive slide. Oh, okay. I'll check it out. Yeah.
So, because my
Yes.
PowerPoint is have the Kate Bakery, then jump to the exploring data and exercise. I think just missing the 2 slides that you show us just now.
Okay. Okay. No issues. I'll share this. No
Thank you,
issues.
sir.
Thank you. Thank you. So far, is everything okay? Are we clear in the understanding? Okay, very good. Thank you. Okay. So we will have a break, okay, for the session. Okay, before we go to the next discussion. Okay. So are we good to have a break now? So you feel more fresh and more energetic? Okay, thank you. Because already 5 minutes passed. Okay, so sorry for that. So we'll start on next session at 11 o'clock. Thank you. Thank you, students. Take care. So for now, I'm not switching off the video. During lunch, we'll switch off the video so that we don't have yesterday's confusion of whether it's recording or not. So everyone okay? Can we progress? So regarding chai, okay. Does anybody also have any issues with this PowerPoint? Because when I check from the Moodle, all the slides are there for that particular chapter. Do anybody also having the same issue, like any slides missing in that particular PowerPoint?
Sir, let me check in the Moodle first because I download from the Teams, the slides.
Oh, okay. Maybe I'll check from Teams also.
Yeah, got it, sir.
Okay, thank you. Okay, fine.
So I think Chai, if I understand Chai question is, I checked already. Actually, there are two slides missing from our PPT. The one with the exploring data, the other one is for exercise.
I think in the Moodle is the updated one. You can download from the Moodle. I just download it now.
I also downloaded it from Moodle, but still oh, okay. The exercise put at the behind. Only the sequence changed.
Okay.
Yeah, thank you, sir.
Just from my side, I cannot really check.
I think it's the order. The sequence is different from ours one. Thank you, sir.
Okay, thank you, thank you. Because do we have the files in the Teams? Did I upload that in Teams or something? Because I don't see files in the Teams. Is it in the class material or where did you check in the Teams?
It's under class material, sir.
Okay, maybe I'll share
I
my.
think class material is missing already. I think it's removed, if I'm not mistaken. It's no longer there.
No, I'm not sure because I'm not. If in case I uploaded, I would not have removed it. And I'm sure nobody else can remove from class materials. Okay.
No,
I think
it's
should be
still
okay.
there. I can see.
Is it? Surprising. Anyway, it's okay. But we don't have that particular slide, right?
All the slides are not there. So I think I downloaded from Moodle one.
Okay, it's from on. So who said the slides are there?
It's Chai, but I think because I remember I download from Teams, maybe I'm
Okay, no
taking the
issues,
wrong
no
place.
issues.
Yeah.
Sometimes Teams also little confused. Okay, no issues, fine. So now I think everybody is having the compact of the lecture slides. So we start the recording. The recording is already started, right?
Yes, started already, sir.
Yeah. Thank you then. Okay, so everyone is clear in this way we describe the data, continuous and discrete, right? Okay, so now this is exercise. Okay, please make sure that you complete the exercise. Okay, and put the answers in the chat. Calculate the mean, median, variance, and standard deviation. So 5 students enroll for data management module. So the students scored scores, okay, and can range from 0 to 100. And the following are the student score. Okay, so 83, 94, 30, 63, and 66. Okay, so for this we are trying to get the mean, median, variance, and standard deviation. So hope you're having the formula. Can we get the answers in the chat? Anybody having doubt in the formula? How to find mean, how to find. Once you find, you can put the answers here in the chat. So we can progress to next slide. Okay, very good. So Chai has used SAS to get the result. Okay, without SAS, can you do it mathematically? Can somebody give the formula? Or usual method of using a calculator? Thank you, Chai. Thank you, Tan. So we have a mean, we have a median. There is no mode. We have some variance, we have some standard deviation. Very good, right? So hope we are clear in this. So S square is a sample variance, which is equal to summation of xi minus x bar the whole square by n minus 1. Because we already have this formula, right? I think we did discuss these things in the previous class, right? Thank you, Yong. Yong V. Okay, so I think everybody is very clear in this, right? No big doubts. So what about the next one? So for the given two vectors, can we identify the mean, median, mode, and standard deviation? Yes, for the given two vectors, identify the mean, median, mode, and standard deviation. Okay, fine, good, right? So anybody having doubt in this? Right? So can we go to IQR? Okay, trying, fine. Okay, so maybe meanwhile we can go with attendance for the ODL, because ODL needs two attendance morning and evening, because then it will not accept. So only for this attendance only for ODL. Okay, for our part-time, okay, we can have part-time and ODL once again in the afternoon, right after the break, after the lunch break, or maybe after the break, no issues. Okay. Yes, Khalid. Okay, those ODL students, please mark your attendance. Q Park.
Yes, sir.
Okay, thank you. ODL students, please mark your attendance. Lee Jinwen, Mohammad Jainal, Noor Farah, Samra Nebang, Wang Mi. Okay, no issues. Lee Jin. Okay, very good. So we have some answers in Excel. Fine. So sure all of you are fine with this. Okay. So interquartile range IQR. Okay. So we have the theoretical understanding because yesterday we just discussed some of the aspects with the diagram, right? So now we have some hands-on with maybe I can give some exercise on this to get your answers. So when a data set has outliers or extreme values, so we summarize a typical value using the median as opposed to the mean, right? So when we have the median, because we have the center value of our data set as such, okay? And as noted, when you're talking about median, please make sure that we sort the data. So without sorting data, median serves no purpose, right? So variability is often summarized by statistics called the interquartile range. So this is how we are trying to get a value out of our interquartile range. So variability is often summarized by the statistical data. So interquartile range is equal to Q3 minus Q1, right? So that is the reason why we put it under the mid part, the 50% of that particular value, right? So in an interquartile range with an odd sample size, right? So whenever we have odd sample size, we usually have the middle number, okay, as our median, right? So when you have the middle number, okay, out of the sorted data, so once we sort the data, we have the least value, which is 63, and the highest value, which is 81. So median here is 72, and we can understand that the lower half, okay, we can have a lower quarter and an upper quarter. So how do we estimate that? Okay, so we try to get the values, okay, which is in that particular range of Q1, which is here we get the values of 64 plus 64 divided by 2, right? That is a range for Q1. Similarly, we get value of Q3 and the interquartile range, right? We are subtracting the value of Q3 minus Q1, right? So here we are trying to get a valid approach of how we are trying to get the Q1, Q3, and from these two values, how we are getting the Q2, right? Hope everybody is clear in this, right? Yes, regarding attendance, we are marking only the ODL in the morning session because ODL is not marked with attendix, it's manually marked. So we cannot have more than 4 hours at a stretch for ODL. Whereas for part-time, right, we can have the attendix, which is giving us the whole day schedule. Okay, so during the afternoon session, we will have both ODL as well as our part-time student attendance. Okay, thank you. So please rest assured, no issues with our attendance. So for now, just only for the ODL. In the afternoon, we'll have both ODL as well as part-time, so that we cover for the whole day. Am I clear? Okay, thank you. So how about our IQR? Is everybody fine with the IQR? Any doubts in the IQR? Okay, fine. Thank you. Thank you, Chai. So with even numbers, right? How are we going to do it? So what we do, we actually take the average of the highest of the lower half and the lowest of the upper half. So which is 70 plus 72 divided by 2. So this gives us the median value, right? So we take the average of these two. Right. So take the average, you get the mean value. The mean value of this 70 and 72 will give us the value 71, that is the median. So similarly, we calculate Q1 to be 64 and Q3 as 77. Okay, fine. So now, how do we justify this value Q1 64 and Q3 as 77? Can anyone remember and just give the value? How do we justify this? How do we say Q1 is 64 and Q3 is 77? Okay, fine. How about others? So how do we calculate this Q1 and Q3? Okay, very good, Ang. Yes, some inputs here. I'm just waiting for some more inputs so that all of them are fine with the progress. Is everybody clear? So please give your answers here. Similarly, can we get some answers in this for this particular problem? So just check the activity. Thank you. We have very good inputs here from Yolok, Kenji, Kong, Ming, Noor Eurasia, Tianyan, Chai, Isaac Wong, Wang Sui, and Wang Men. Okay, then. So it means that everybody has good understanding on this, no issues, right? So when can have the very good understanding on this fine. So similarly, when we apply the interquartile range IQR to determine the outliers that exist in the above distribution, height measures of the graduate students, right, are reported as follows. So we have some values here. So all these are nothing but height measures. Okay, so the categorical data. Okay, before going, I think everybody is clear in this, right? No issues, right? Can you progress? So okay, very good. So in categorical data, right, we're discussing about the frequency distribution and frequency table. So we are trying to organize the qualitative data into a frequency table. So if in case you remember, yesterday we discussed about the frequency table, how we are using it in SAS. So now we are trying to bring out some understanding on the theoretical nature of it. So to present a frequency table as a bar chart or a pie chart, and also to organize quantitative data into a frequency distribution, right? So we can organize in such a way and present a frequency distribution for quantitative data using histograms, right? Or also you can use frequency polygons and cumulative frequency polygons. So some of the discussions we do with some good diagrams. Okay. So here as such, a simple frequency distribution. The frequency distribution is provided here for those selling prices which ranges from few $1,000s, right? Like 15,000 to 18,000. The frequency is 8, which means the number of observations that has been recorded is 8.
A semicolon, and here is the run button.
Yes. We have another class going on, is it? Yes, middle class, can you hear me? Because I heard something else. Okay, it's okay, no, fine. No issues. Okay. So a frequency distribution is a group of data into mutually exclusive categories showing the number of observations in each class, right? So the table shows a frequency distribution for a set of quantitative data. So here you can see the number of observations in frequencies, right? How many times that particular value has occurred, right, in our particular data set. So to bring it out as a frequency table, the frequency table discusses a grouping of qualitative data into mutually exclusive classes showing the number of observations in each class. Okay. So here when we go with the frequency table for vehicles sold at a particular dealer, right, for a particular time period, you can see that type of a car, okay, number of cars sold. So this is giving us a detail about the number of observations recorded over a period of time, okay, based on the frequency, right? So discrete statistics can all deal with the measure of location, which is based on the mean, median, and mode, right? I think just now you'll be doing those exercises. So central value is all about giving information concerning the average or typical score of a number of values provided in the particular data set, right? So number of scores is mainly based on the mean and median, right? So mean gives us the average of the data set, and median gives or exactly divides the data set into half. The only thing to be noted is to be solved, right? So central value, the mean, is a measure of the central value, right? So here don't confuse with the central value in the terms of the median, right? Here they're talking about the average. What people mean is average, sum of a set of numbers divided by the number of numbers, right? Or the total number of observations. Sum of all the observations by total number of observations, or the particular attribute as such for the particular attribute. So this is typically when we have some values like 1 to 10, okay, you add them and then you subtract, and then you divide by the number of observations. So regarding the mean, for a sample, you say mean is summation of x by n, right? For the population, you give mu equal to summation of x by capital N for sample size and population. The sample size is based on the data taken from the main population. So when we have this value x, right, summation is divided by number of observation, which is 5.5. Okay. So this is just to make sure that all of us are very clear in this understanding, so that if in case anybody is very new to statistics. So the middlemost or the most central item in the set of ordered numbers, it separates the distribution into two equal halves. So if it is odd, the middle value is very clearly defined. If it is even, then the average of the two middle values should be taken. So here you can see 9 is the median in the odd value and 9.5 for the value which is going to be even values. So median is not affected by the extreme values, right? Because it is just not the average, it's just the middle value. So this is a very important question, like when to use what, right? When are we trying to use which particular central value? So mean is a great measure because it gives us the average, but there are times when its usage is inappropriate or impossible. Okay, so for this, maybe we can get some more justification. So when it is a nominal data, right, we go with the mode. When it is a nominal data, we go with the mode. Okay, so can we give some examples like nominal data and why we go with the mode? Not a median or a mean. Yes, class, is the question clear? So the question is, maybe you can give some examples. Sorry. When we have some nominal data, we go with the mode. Yes, very good from on. One, because we cannot sort by order. So usual nominal values, are they categorical values? Or what type of a value is it? Okay. Picture is giving more clarity here, right? Nominal data divides variable into mutual exclusive labeled categories, right? So usually something like when you have a name, right? Or when you have some sort of an understanding with this particular type of a data. So example like eye color, blue, brown, green, or a smartphone, this is iPhone, Samsung, Moto, right? So how is a normal data analyzed? So here we cannot go with a type of mean or a median value. We can go with the mode. Okay, so what mode can we go with if in case we identify, right? We say mean is a great measure, but we say there are times when its usage is inappropriate or impossible. So we go with the nominal data. So in which place? So maybe you can give some example justifications, anybody? So we can have more examples, more type of discussion here. So if in case we have a missing value, right? So what are we trying to put inside the particular missing value? Is it going to be a mean value or a median value or a mode value? I think the question is clear. So this is how we are trying to make sure that, okay, Trisha is saying that it is a mean value. Okay. Other inputs. Ang has already said because we cannot sort by order, we go with the mode. From Chai, for nominal data, the missing value is replaced by the mode. Okay, fine. So are we clear with the mode? We discussed mean, we discussed median. Is anybody having doubt with the mode? What is the meaning of mode? Yes, anybody having doubt with the mode? What is the meaning of mode? Of course, maybe we can have some doubts, no issues. Is everybody clear with what is a mode? Or when do we have this idea of mode? Thank you, NG. Good. Mode usually nothing but most occurring data, right? Or mode is the value which occurs the maximum number of times in a given data set. Okay, good. So now we understand that mode is the maximum number of times particular data is being occurring, right? So in general, we have only few number of items, okay, and we see that this value is really not giving us some sort of a calculation, but it is based on this particular value that observation can have some sort of a detailed discussion. So during that case, we can have some sort of an understanding whether we want to go with a mean or a mode, right? So if it is n number of observations and based on occurrences of the data items, we go with the mode. How many of you are able to understand this? How many of you are able to clarify this? Anybody having a doubt on this? Because it's not that every time we use only a mean to fill in missing values, because we said that we do not want to delete any missing values, right? So we want to use some values to populate them to fill the gaps, right? So when we have this type of nominal data, we usually go with a mode, right? Number of times that particular value is occurred. Similarly, when the distribution is bimodal, we go with the mode. When do we say a distribution is bimodal? When do we say a distribution is bimodal? Very good. Shah is giving a compact answer, and we have some good definition from Dan. Bimodal has two modes. Good, right? No doubt. So two modes in the data distribution. So for example, data distribution of kids who are weights A class might have two modes, boys and girls. A bimodal distribution means that there are two of something impacting the process. So if the data set has more than two modes, it is an example of multimodal data distribution. So if it is just two modes, like you're having here data distribution of kids' weight in a class, right? Okay. So during those cases, why do we say that we want to go with a mode and not a mean value? Of course, we don't want to go with the median, but why is it that we want to go with a mode value, not a mean value? Yes, fine. Okay, this frequency is stable. Anybody in the statistics? I'm sure many of them are experts. So in this type of bimodal distribution, right, we are understanding that we don't want to go with an average, but we do want to go with a mode. Agreed? Any doubts? Okay. So when do we actually have an ordinal data, right? So if in case I want you to refresh based on our understanding on this particular thing. So we are discussing about qualitative, categorical, and attributes, right? So when you have ordinal data, we're talking about ranks. Remember, nominal, ordinal, interval, and ratio, right? So when you're talking about ordinal data, okay, we are very clear that it is based on some sort of a ranking, right? So when you're talking about ranking, it's not a good thing that we take a mean, right? We go with a median or a mode. Okay. Or when you have few extreme scores, we go with a median. So the question arises when we talk about these things like mean and median and mode. So when actually are we going to go with a mean? When actually we can go with taking the mean value for filling our missing data. Yes, do you understand the question? So if in case we have the group, right, and the group says that it's based on the particular criteria, okay, of the values within a particular range. So those people who are eligible to vote. So during those cases, what we can do, we can go with the justification of taking the mean value, right? If in case you're taking an example of a set of people of all age groups, right? So starting from people who are in kindergarten to those people who are senior citizens. So during those cases, what is a type of a value that you can take to populate the missing data. So in that case, can we really go with the median or the mean? Surely we don't have more than that because it's not a nominal data, it's a continuous data, right? Agreed? Are we clear in this? Okay, from TAN we are having this understanding that when data distribution is symmetric, yes, good, right? And similarly, when to use the mean, it is best to use the mean to describe the center of a data set when the distribution is mostly symmetric and there are no outliers. So if in case we have outliers and we know that the value can be symmetric when we remove the outliers, please we can eliminate the outliers, make our data symmetric, and then we populate those missing values with the mean. Are we getting a clarity on this? Thank you, Wang. How about others? Because this is a little important thing that we need to put in our assignment. That's the reason why I'm just getting your outputs and what is your understanding on that particular aspect. Anyway, we are having very good inputs here to have more clarity. Anybody having any doubt on this? So are we clear when we need to put a mean or a median or a mode in the missing values in our data set? Right? Can we also have some understanding that we can also take into consideration some other attributes when we wanted to go with populating with the mode? Yes, Lokshan, yeah, correct. You can give the justification because it gives more clarity about why we want to do it. Very good. How about others? Are we clear in this understanding why and what are we trying to do with filling the gaps in the missing data? Okay, fine, no issues. Good. I think others will also follow suit. If anybody having doubts, okay, please put it here. We can discuss. Okay, fine, good. Right. So this is actually, I think these things we already did discuss small, right? No issues, right? We're just putting it in a pictorial form, like how a more symmetric data looks like, which has all the mean, median, mode in a good bell-shaped curve, right? And for those which is negatively skewed, you very well know that median is going to be well right side of our mean, right? So whenever we talk about this type of skewness, right, we usually go with the median because median is the central part, right? So when we see that the median and the mean value, okay, and when the mean value is towards the right or when the mean value is towards the left. So when we see that the mean value is towards the right of our median, you can see that the tail is towards the mean and it's a positively skewed one. And when the mean is towards the left side of our median, the tail is actually in the negative skewed side, right? Are we getting understanding on this? Right. So please make sure that all these things we are measuring only with in terms of the median. Clear? Any doubt on this? Okay, fine. So in kurtosis, we're trying to distinguish between two samples. So here we're talking only between one particular sample, right? When talking about two samples, right, we can take into consideration the kurtosis, right? So for now, we don't want to put that into this picture. Okay, Caleb. So are we clear with this understanding now? Thank you. In continuous data, right, for descriptive statistics, the measure of variance, standard deviation, range, and interquartile. So we'll have some more activities here. So range is a spread of the distance between the lowest and the highest values of a variable. So to get the range for a variable, you subtract its lowest value from its highest value. Right, so this is how we get the range, as simple as that, right? So in class A, class B, we have two distinctive things. Okay, so in class A range, we have values ranging from 89 to 140. So we subtract 140 from subtract 89 from 140, we get the value. Similarly, in class B, we subtract 80 from 162. So which also tells you that you need to have an sorted value so that you know which is the min and max values. Okay, this is about the range. So we get the range by subtracting the lowest value from the highest value. So the interquartile range, right, as we discussed, it's all about getting our percentiles. So the lower percentile and the higher percentile. So a quartile is the value that makes one of the divisions that breaks a series of values into 4 equal parts. Right. So the median is a quartile and divides the case into half. Okay. So the 25th percentile is a quartile that divides the first quarter of a case from the later 3/4. Similarly, the 75th percentile, which is our Q3, right, is a quartile that divides the first 3/4 of a case from the latter 1/4. So here we are trying to get our least bound and upper bound. I'm sure all of you are very much familiar now. So the interquartile range is a distance or a range between the 25th percentile and the 75th percentile, which is 50% of the entire range. Right. So this 25 from the lower and 25% of the upper will give us the entire quartile, the interquartile range. Okay. So standard deviation, to convert variance into something of meaning, let's create a standard deviation. So I think we already have the formula with us, right? So standard deviation is root of. Okay, can we have the simple abbreviation here, right? So which is something but y bar will give us the mean, right? So yi minus y bar by n minus 1. So those individual values minus the mean by n minus, which is n is nothing but the number of observations minus 1, right? Hope all of them are clear in this, right? No big issues. Okay. Yes, Kong, very good. Okay. Any doubts in this? Clear, fine, good. Okay, so we're just trying to get the values, okay, based on the class A. Okay, here the standard deviation we get, when you do the square root, we get 15.34. So the average of a person's deviation from the mean IQ of the given value is 15.34. So we can just get an understanding about the standard deviation. So when we actually go with the standard deviation variance. So I think we are clear on that, right? Yes, class. Okay, fine, good, thank you. So the larger the standard deviation, the greater amount of variation around the mean. Okay, so here we can go with the reason why it is more skewed, right? Fine. When you see check here, I think we have some more inputs from Kong. So we're talking about whether data is heavy tailed or lightly tailed. Okay. Okay. So when we go with this type of an understanding, we understand that we are taking into account both the before and after effects, like how we discussed. Okay, when we want to go with a paired t-test, or when we want to go with assessing, right, the two-tailed test. Okay, right. Thank you, Kong. Thank you, Chai. Hope you are progressing well. So for this example, okay, so we have the variance and the standard deviation. Okay, so standard deviation 0 when all values are the same, like only when you have a constant and not a variable. Okay, so this gives us the clarity on how we are calculating the distribution of the data in a data set, right? How data points actually act in a particular set. So if you are where to rescale a variable, the standard deviation would change by the same magnitude. If you change the units above 30, the mean is equal to 250. Right. So standard deviation on the left would be 30 and on the right should be 60. Okay. So what are we trying to understand with this term called rescale? If you want to rescale a variable, the standard deviation would change by the same magnitude. Okay. So are we getting an understanding, like when we rescale, what are the terms that we have used before? When you want to scale, what can we do? The usual method. Can we go with the normalization? The scaling. Yes, I'm just not sure. What about others? When you want to scale, can we go with normalization? Or normalization is one of the way of scaling. Okay, so what are we trying to do when you do normalization? Okay, from okay, very good. What do we do with normalization? If you remember, we discussed this maybe in the second slide or maybe the second chapter. No. In normalization, we don't do. We're not talking about duplicates. Okay. In normalization, we are scaling actually. Okay. So when we have a very wide range of values, yes, correct, right? We can change the value from 0 to 1. So which means that we are trying to scale it in terms of the values, right? Are you getting it now, Ang? How about others? Here we're not trying to remove duplicates. We are trying to scale the values, right? Okay, now next. Okay, now we know what is normalization. What is the effect? What is the reason why we go for normalization? Homogeneous data. Very good. Okay. Any doubts? So I think all of you are very clear in this, right? This understanding. Anybody having any other doubts? Very good. Okay, it's very good question here. Normalization and standardization. So we are very clear when we normalize, we're trying to scale, right? 0 to 1. Fine. Okay. What about standardization? Really good input. When do we go for standards? Or we can just understand with these terms like standard, right? When we go with standard or when we standardize something. Yes, because I can give you a very good example here. We do have this in slide. It's a often used, often, right? Okay. That is no way I said. Yes. Okay. I think we remember this. Very good. Okay. We did discuss this, right? Remember? You, Lakshan? Thank you. Thank you. How about others? It's a very good question. Thank you. Thank you, Ulok. That's the reason why we said why we go for standardization, standardized. Okay. So now we have some activities here in IQR. I'm sure many of them are already hungry. Okay, just some few more minutes. Okay, we'll go for the break for the lunch. No issues. Okay. Okay, fine. So any doubt in this? Are we able to get clarity on this? Thank you, An. Thank you, Lakshan. Thank you, Kalib. Thank you, Chai. Fine. Okay, so now we have some practical application that we need to understand here, right? So in standard deviation, we are trying to note about the computational formulas. So your book provides a useful shortcut formula. So for computing the variance and standard deviation. So this is intended to make hand calculations as quick as possible. Okay, so they observe, or what we're trying to do it in a standard deviation for calculating. Okay, so nowadays we can also use tools that's more effective, right? We can use effective tools like Excel also can give us some good idea. So this obscure the conceptual understanding of our statistics. So that is why, okay, we just wanted to say that we need to have some sort of an understanding on this particular aspect. So SPSS and the computer or computational formulas are nowadays also being used. Okay. So the practical application for understanding variance and standard deviation. So even though we live in a world where we pay real dollars for goods and services, not percentage of incomes, most American employees issues raises based on percentage of salary. Okay, now we are trying to think in terms of real-time applications of where we are using it. So why do superiors or the supervisors think the most fair raise is a percentage rise? Okay, so even when you see that the rise, say that okay, the budget is raised by this particular percentage or tax is raised by the percentage. Okay, and the reason why is because the higher paid person win the most money. Right, the easiest thing to do is raise everyone's salary by a fixed percentage. Okay, do everyone agree to this? Why we fix everything in percentage, right, and not in a slab or something, right? And it's also can we just put that in terms of understanding whether percentage increase is also something related to the slab increase? Are you able to understand what I'm trying to say here? Percentage and slab. In case we are trying to put some household incomes, like low income, middle income, and high income, it's a slab, right? If in case we are talking about percentage of income, or if in case you wanted to rise percentage, okay, why we go with this type of an understanding? Yes, anybody having this clarity on that? Okay, that is the reason why we are talking about a practical application here. Okay, so that we are able to visualize what is happening. So maybe you can take an example here. Okay, from one particular service, right here they're talking of a particular toilet cleaning service where they are paying a salary equivalent to something around 200,000. So income ranges from president to the actual person who is working on the field. Okay, so the mean, when you talk about the mean, you can check that it is something around 50K and the range is something around 90K because we're subtracting the mean and the max, the min max values, right? That's the range. So variance is how you calculate the using the particular formula and standard deviation root of variance. So now let us apply a particular value, maybe range of 5% increase. So this can be considered a measure of inequality. Why they put as measure of inequality? Okay, you can see here if in case it's a 5% rise, the pool of money increases by 10K to 210,000. Why? Because only the mean went up by 5% and the range went up by 5%. Right? You can really see there is what is the big deviation in the variance and the standard deviation. Right? So the fact percentage rise is increasing the inequality. Are you able to get this understanding? Why we are talking about the inequality? We say there is increase. We put as a 5% increase. So the 5% increase for 10,000 is how much, and the 5% increase for 210,000 is how much? Is it clear what we're trying to justify here? So this is the reason one particular thing you can also justify in your assignment. Okay, if in case you're talking of particular financial details in your assignment, okay, what if you're going to put this as an hypothesis? So this is one question of hypothesis. Maybe you can also have 2 questions arise with this type of hypothesis. Is it clear, my dear class? Any doubts? Are you able to understand what I'm trying to convey here?
Sorry, sir. I'm trying to link with scaling. Is it something to do with scaling as well? Increase by percentage, so that everyone are having the same percent increase, and then it won't
No.
affect.
Okay, here we're not talking about feature scaling. Here we're talking about the way in which the data can be normalized. Okay, we can also don't put in the terms of normalization. Okay, we can say that how we are understanding the variance and standard deviation, because this is not with any feature scaling. That we don't go with any type of that particular nomenclature, but we are trying to discuss about how are we getting some sort of an hypothesis to be understood. So because in your assignment you need to go with some hypothesis, right? Some justification to be provided. So if in case you have this type of an 5% increase, what will happen? It's not related with feature scaling.
Great, sir. Thank you, sir.
Okay. How about others? Anybody can relate this with hypothesis that you wanted to postulate? Is it clear? Any doubts? Yeah. Okay, so you can just use this as an hypothesis, and you can just state it's a weak hypothesis setup. Good. How about others? Everybody? Any other inputs? Is everybody clear in this attempt? Or any doubts? Okay, so here we are just trying to say that what is the attempt in case we are understanding the variance and standard deviation in this case, okay, and whether we can put an hypothesis for test and then we can bring out a solution. Just for clarification and justification, okay. Okay, class, can I proceed? Okay, very good. Thank you, Chai. Thank you, On. So you will see here. Okay, so now we are going into more examples here. We're trying to compare what will really happen here. Okay, so the flat percentage rise increases inequality. Okay, so you can mention that. So the top earner gets 50% of the new money and the bottom earner gets only 5% of the new money. Inequality increases by 5%. So since we pay for goods and services in real dollars, not in percentage, there are substantially more new things the top earners can purchase compared to the bottom earners. So how they compare it, right? So if in case they want to buy a new TV, in addition to everything they else to buy, you can see here what type of a thing they can buy, right? So based off that increase, what they can really buy and what they can do. So the gap between the rich and the poor is actually expanding, right? Because of some progressive terms of the way they have been distinguished. Right. So for example, 5% or $1,000, whichever is greater. So this is what we wanted to say. So for example, that is why some progressive organization give a percentage rise with a flat increase for lowest wage earners, which means it's going to be flat around, for example, 5% or $5,000, whichever is greater. So does this sound more applicable? Right, which means that we are not talking about measures of inequality here. It is more just. Agreed? Yes, Chai. Right. So this is the reason why we are trying to put it here. Okay, like how we are going to go with an hypothesis, right? How we are trying to justify this. Because I know that you are also going to write some hypothesis for your data set, right? So this is one way of doing it. Is it clear, my dear class? Is everything okay? Are we progressing well? Can we get some inputs here in the chat? Hope everybody is fine. Okay. Aruthiban is here. Okay. So I know some of them said they wanted to join late. I'm sure all of them are here. Calib is okay, fine. Hong is also okay. Chai is okay. Any other doubts? Right. So I think we are fine with this discussions, right? So maybe afternoon class we can have some more lab sessions, and then we can discuss one of the sample assignment. Okay. Very good. Thank you, Ang. Okay, can we discuss visualization now or maybe after the break? Because I'm sure many of them are not already tired now. Can we do visualization now or can we do it after the break, after the lunch break? Okay, thank you. I can feel the pulse. Okay, thank you. Okay, please have the break. Okay, we stop the recording for now. Okay, and then we will start the recording at after the break. Okay, you will have this lunch break. So we'll start at 1:30. Thank you, class. Good day. Thank you, everyone. Okay, Zainal. Okay, just give me a second. I'll check it out.
Sorry, sir. So we can log out and then log in later at 1:30, right?
Yeah, sure. You can.
Okay, thank you.
Thank you. Thank you, Prem. Okay, done, Zainal. Okay, I'm sure all of you are fine. Thank you, Zainal. Thank you, Unisha, Lok, Angpao. Thank you all. Good day. Meet at 1:30. Wang Pai and Wang Ming. Okay. Wang Pai and okay, not module means we will do it in the afternoon session. Okay. Arul Tiban, for part time, we'll do it in afternoon because part time we'll have it as a whole one. Only for ODL, we are having this difficulty of more than 4 hours.
Okay, sir. Sure.
Okay, man. Thank you. Good day.